Hey everyone, today we're going to dive into some hidden engineering behind something you'd think is super simple, stirring. Turns out, when it comes to making your favorite yogurt or ice cream, there's a whole world of science behind getting that perfectly smooth texture.
So here's what we're going to cover. We'll start with some key ideas, then check out the actual tools they use. After that, we'll look at a really common problem and how engineers solve it, talk about the cost of all this power, and finally run some numbers that might actually surprise you. Let's get into it.
All right, first things first, we got to get our terms straight. Because in the engineering world, just saying stirring doesn't quite cut it. There's a subtle but really important difference we need to understand.
So here's the deal. Agitation is just the action. It's the process of getting the liquid moving around in a circle, like keeping milk from settling. But mixing is the goal. It's making sure all the different ingredients are perfectly blended together. See the difference? One is what you do, the other is the result you want.
And this one process, agitation, is like a Swiss Army knife for the dairy industry. It's not just about stirring a little. It's how you keep solids suspended for ice cream, make sure heat gets distributed evenly during pasteurization, and even create those super smooth emulsions you find in cream. It's a real workhorse.
Okay, so how do they actually do all this stuff? Well, let's take a look at the specialized gear engineers use to make this happen on a huge industrial scale.
You know, it all starts with the container itself. And this shape, a cylinder with a rounded bottom, is no accident. It's designed very specifically to get rid of any dead spots where liquid could just get stuck and not mix. The whole point is to make sure every single drop is in motion.
Now, inside that tank, you have the agitators. First up, you've got propellers. And yeah, they look pretty much like the ones on a boat. They're built for one thing, moving a lot of liquid efficiently. They create this powerful column of fluid, shooting it straight down or pulling it straight up.
But when you need some serious muscle, you bring in the turbines. Now these work differently. Instead of pushing fluid up and down, they fling it outwards from the center with a ton of force. This creates what's called radial flow, and it's absolutely essential for tougher jobs like breaking apart clumps or making really stable emulsions. Okay, but here's the thing. When you're stirring that hard, especially with one big mixer in the middle of a tank, you create a huge common problem that engineers have to be pretty clever to get around. It's the vortex. You've seen this a million times stirring your coffee. While it looks kind of cool, in a food processing plant, it is a total disaster. That little funnel can suck air deep into the mix, and that can completely ruin the texture and shelf life of the final product. So that's the big question, right? You need all that intense motion to get a good mix, but that very same motion creates this vortex you have to avoid. So what do?
Well, it turns out they have a few really clever tricks up their sleeve. You can move the mixer so it's not dead center or even angle it a bit. But one of the most popular and effective tricks is to install baffles. They're basically just vertical strips of metal on the tank wall that act like speed bumps for the fluid. They break up that circular flow and kill the vortex before it can even get started. Simple, but it works.
All right, let's talk about the thing you can't see, but that matters a lot: energy. Moving thousands of gallons of milk or cream around takes a serious amount of electricity, and, that costs money.
This quote really just nails it, doesn't it? It's the constant challenge for an engineer. You have to get that perfect mix, but you have to do it as quickly and as cheaply as possible. On a big industrial scale, that efficiency is everything.
And here's where things get a little counterintuitive. A really good mix doesn't come from a nice, smooth, gentle current. Nope, it comes from chaos. The goal is actually to create controlled turbulence, all these little eddies and swirls that force different parts of the liquid to slam into each other. That's what really gets things mixed up.
Okay, enough theory. Let's get into the numbers. We're going to look at a couple of quick examples that show how tiny little changes in the setup can have a massive impact on how much power you need.
So just picture this, a pretty standard setup. A 6-foot tank, a 2-foot turbine spinning away, and, this is important, those 4 baffles on the wall to stop the vortex. Okay, to run this thing properly and get a good mix, the math says you need 3.31 horsepower. Just remember that number. That's our starting point.
But now, what happens if we just take out those 4 little strips of metal, the baffles? Get this, the power needed drops all the way down to just 0.74 horsepower. I mean, wow, right? That looks like a huge win.
But wait,
This is a total trap. Yeah, you just cut your energy bill by more than 75%, which sounds great. But the vortex is back, air is getting sucked into your product, and you've completely failed at the one thing you were trying to do, which was mix properly. It's a classic example of false economy.
Okay, let's try something else. We'll put the baffles back in. But this time, let's swap out that thin liquid for something super thick, something 10,000 times more viscous. What do you think happens to the power needed?
You'd think the motor would be screaming that the power would go through the roof, right? But look at this. It only goes up to 5.34 horsepower. Just let that sink in for a second. It's not what you'd expect at all.
This is just one of those amazing moments where your gut feeling is completely wrong. We made the liquid 10,000 times thicker, and it only took about 60% more power to mix. It just goes to show you how weird and unintuitive fluid dynamics can be.
So yeah, it's a pretty cool reminder that behind even the simplest things we buy, there's a ton of really smart engineering. It's this whole balancing act of physics and power and efficiency, all just to get that perfect taste and texture. Definitely something to think about next time you're in the dairy aisle.